So working on an example where Anne is racing her younger brother Lee, and Anne decided to give Lee a head start of 10 meters. So we made a table of values, and Anne started at time 0. She had 0 meters head start because she started at the starting line, but her brother at time equals 0 had a 10-meter head start. These are similar, but there's a big difference here. Anne's has a y-intercept of 0, and Lee's has a y-intercept of 10. Anne's situation is called direct variation. While Lee's is called partial variation. So why direct? Because it goes through the point 0, 0. The distance always increases at a constant rate compared to the time. When you go one more second, it goes up by 3. You go up one more second, it goes up by 3. There's always this constant rate, and they start together at 0, 0. In Lee's case, he had a head start. It doesn't start at 0, 0. After that, there is a constant rate it increases by. The time goes up by a second, and here it goes up by 2. Time goes up by a second, distance goes up by 2, and the distance is going to continue to go up by 2, but they don't vary directly with each other, the distance and time in Lee's case, because at t equals 0, d is equal to 10. We can see this difference on the graph as well. So in Anne's case, she starts at 0, 0, and from there on out, as time increases, the distance increases. That's very important. And again, this is called, what was it called? Do you remember? Direct variation. You're going to write that one down. But in Lee's case, he gets a head start. He's not at 0, 0. So the amount of distance, the rate that the distance is increasing, is not the same all the time. He starts at 0, 0. He doesn't start at 0, 0, so in that first seconds, he's already gone 12 meters. At the second, he only goes 14. He's up to 14 meters. So the first second, he's had such a bigger distance than in the next second. If that makes sense to you. Try your best to keep the two straight. Just remember, direct variation goes through 0, 0. Partial variation does not. Whether you're looking at the table of values or the graph. Okay, the final thing to look at is the equation. Maybe you've already thought about the equation, or maybe you haven't. It's going to look something like distance is equal to something we have to do to time. So let's walk through it a little bit and see if we can figure it out. At time, oh, that's not correct, is it? A little higher. There we go. At time equal to 1 second, Anne has gone 3 meters. We saw that in the table of values as well, didn't we? At time is equal to 2 seconds, she's gone 6 meters. At time is equal to 3 seconds, she's gone 9 meters. And it just continues in this same kind of pattern. So what do we need to do to the time to get the distance? 1 times something equals 3, 2 times something equals 6, 3 times something equals 9. Do you see the pattern? We have to multiply by 3. That's it, that's all. Direct variation. It's quite simple. Partial variation. So in this case, at 1 second, he's up to 12 meters. At 2 second, he's up to 14. At 3 second, he's up to 16. At 4, he's up to 18, and so on. So let's try to figure out an equation for this situation. We have a dependent variable of d. The distance depends on the time. Okay. So in our direct variation problem, we just had to multiply the time to get something. This situation is a little bit different. If we try to just simply multiply, will that work out? We would need something times something equals 10, and something times, so like for something here, something times time, so this is, in time is 0, time is 1, okay, something times 0 equals 10. Uh-oh, anything times 0 is always equal to 0. This is why it fails. What we actually need to do is have a plus 10. Something times 1, so we know this equation has to have a plus 10. Let's box this off because it's important. Okay, so at 1 second, the distance is 12. Something times 1 plus 10 is equal to 12. Something times 1 plus 10 equals 12. So what do we have to add to 10 to get 12? We need to add 2. Something times 1 equals 2. 2 times 1 equals 2. 2 and 10 is 12. Alright, so it looks like we have to have something times the time plus 10. 2 times the time plus 10. That looks like it's the equation. We should always check another point just to be sure though. So at t equals 3, let's see what happens. 2 times t equals 3 plus 10 is equal to 2 times 3 is 16 plus 10. 2 times 3 is 6 plus 10 is 16. Okay, so we think it should be 316 according to this. 316. Yes, it is. The point is 3 comma 16. Alright, so we have found the equation. In general, direct variation will always pass through 0, 0, and the equation will always look something like the dependent variable is a number times the independent variable. So y equals mx is how we like to say it. We really like using these variables, y, m, and x. We use them quite a bit. Unless it's an application question, we have distance and time, then d and t work out really well. Partial variation. So this does not go through 0, 0. It does not go through the origin. And the equation, maybe I should leave that there for you to see, the equation is going to look like the dependent variable is equal to a number times a variable plus a number. And we like to use mx plus b. We'll talk more about m, what that is. We're going to study that a lot. And we've already talked actually about b in this lesson. So in this case, in the position of b, we have 10. What was 10? Do you remember? Let's look back up at the graph. 10 was the y-intercept. So in the equation, when we have b here, that is the y-intercept. Okay, and it's time to do a little more practice and get started on your homework.